recursion is quite a complicated topic. Now, this is where a function calls itself. It leads to some very elegant solutions, and some of the famous computer science algorithms we're going to go through in future videos, some of them do use recursion. So I wanted to do a little video trying to explain how it works and what it is, just so that everybody understands should it come up in the future. If you feel like this is a little bit information overload at the minute because you've got to be quite advanced in your programming to ever want to use this yourself, feel free to skip it, but do know this explanation is here and you can look back on it in future dates should you need to. So let's take for an example the factorial of a number. So for those of you that don't remember when you learned it in maths, if we did factorial of 4, so something like that, what that effectively means is, what is the answer to 4 times 3 times 2 times 1? Okay, so we can make a recursive function that will do this for us. So we could do def factorial, and we could pass it a number. Then what we could do is we could work out what we call the base case. So I'll come back to this in a little while, but we could say if number is equal to 1, return 1. Otherwise, I want to return number times by, and then I want to call the function again, factorial, but this time I'm going to say number minus 1. So if we call this then, and I'll explain this in much better depth than this, but if we call this and we say, I don't know, let's pass it 5. Let's pass it 4. Let's keep the maths simple for those that aren't as confident in maths. Oh, I need to print it, don't I? Of course, because I've returned it. Print. Okay, so this is equal in 24. So if we go through it, if you imagine 1, it doesn't matter which way around you do it, 1 times 2 times 3 times 4. So 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. So it's working, but now we need to try and understand how and why it's working. So the best way of doing that is let's try and trace through it, and we'll print out a little message so we can see what's going on. So if we print out here, let's print out format, and we'll print out num times by factorial num minus 1, like that. So we can essentially print out to check what is going on here. So when we run it now, you can see it's printing out 4 times factorial of 3. So at this point, it's a sum, but it's only got the answer on one side of this equation. So it knows one side is 4, but it doesn't know until it's explored and called this function what the answer to that is. Okay, so what happens is it puts this sort of data onto what's called a stack. So we'll come back to this in a minute, but what we call a stack of data. So we're going to put this and park it on until we've got an answer. We're then going to the next function call. So when it's factorial 3, that results in 3 times by factorial of 2. I still can't do that maths because I don't know, that isn't an integer, that's another function call. So then I go into 2 times factorial of 1. So now we're getting somewhere, because what happens is when it becomes factorial 1, if you look, when you've passed it 1, it says if the number is equal to 1, return 1. This is what's called the base case. So this is the point at which it's going to return something that isn't another function call. So that's the base case. So we've got to the end effectively. So if we return 1 here, if you imagine that function call there is the number 1. Okay, so then it does 2 times 1, which is obviously equal to 2. So then what it will do, it will go back through the stack. So it will go back through this chain. So then factorial 2 becomes 2. So then it does 3 times 2, which is 6. So then the result of this becomes 6. So then it does 4 times 6, resulting in 24. Okay, because then it can finally go back to the printout. So it's called this function 4 times. I called it at the start with function 4, factorial 4. Then within that, it then called 3, 2, and 1. So there's been 4 function calls. And effectively, it calls each one. So it puts this one onto the stack, then factorial 3 onto the stack, then factorial 2 onto the stack. Then when it's running factorial 1, it doesn't need to put it on the stack because it's running it. Factorial 1 returns a number. So then it can effectively pull the other items off the stack and complete them. So factorial 2 gets pulled off the stack and completed. Factorial 3 gets pulled off the stack and completed. And therefore factorial 4 can finally be completed, resulting in the output of 24. I've only printed that out to try and help the demonstration, but I appreciate this is complicated. It would actually just result in that. Okay, so you can run this, just show you how fast computers are. We can run this for much larger numbers and it would still work. Oh, actually, in this case, it hasn't worked. I'm going to come on to that in a minute. Probably gone a little bit too far. Still too far. Let's go 54. There you go. So what we witnessed there is actually incredibly famous. So what happens is when we look at these stacks, so hopefully I'll add a drawing over this so it'll help you understand. But when you're looking at these stacks, the stacks is going to use part of memory. So to be able to save the different outputs of these function calls so that I can go back through and complete them later, I put them into memory on what's called a stack. Now that stack can only be a certain depth by default. And that's just to do with the available pool of memory that you're using. So we've got these little bits of memory. If I go too far, I'm going to run out of memory. So 3 digits is clearly okay. And then I start getting this. So this is saying recursion error, maximum recursion depth exceeded. So I've been trying to complete this effectively and I've ran out of memory on my stack to put it in. So that's actually called stack overflow. So if you all know that famous website where people can go on and put programming problems, it's named after Stack Overflow, which when you're doing some really complicated maths problems, it's not uncommon to get a Stack Overflow error, which is what you're witnessing in front of you now. So I've ran out of area on my stack. Okay, so that is what Stack Overflow is, and hopefully that helps you understand recursion. Like I said, this is we've gone up a real level compared to the previous videos, but I want you to understand what recursion is because it is going to come up in some future algorithms and it's incredibly complicated to some people. This is one of the areas they find the most difficult. There's a lot you can do as a programmer without needing to necessarily implement recursion yourself if you find it difficult, but I want to make sure everybody understands what it is.